Hello Clansman enthusiasts, it's Alex here, Victor Kilo 2, Papa Radio Charlie over here in Australia. Haven't done any videos for a little while, just undertook a repair, so I thought it would be valuable to the Clansman community to contribute a little bit of knowledge about these battery chargers, the DCCU, and this particular one is a 28 volts version. This is the crook one. This is a good one. I've wired them up in parallel just to look at a little bit of comparison stuff, which sort of helped me in a little way into finding the fault with this one. But okay, so this particular battery charger was given to me by a club member, one of the clubs I belong to. It came out of a ferret armored car, and he said it just failed, so it doesn't work at all, zero. Turn it on, absolutely nothing happens. Okay, so if you're tuning into this for the first time, I have got a very extensive video up on my channel concerning this battery charger as a whole. And I'll refer to that earlier video as I go along. All right. So, yeah. So as I say, it arrived here not working at all. So I've pulled up the manual on my iPad, printed out a circuit diagram for this particular board, and we'll take it from here. Okay. So away we go. Okay. If you've sort of studied my previous video concerning these battery chargers, you'll realize that the bottom board on these particular battery chargers is used, one of the things that it's used for is to generate a stream of pulses, which goes to a transformer on the middle board, and the transformer on the middle board creates a high voltage that is rectified and comes up here to the top board. So all of the discussion today is going to be concerning the top board, and this particular board is the control board for the charging of the battery charger, which charges up the Clansman batteries. Okay, so yeah, the first thing that I do when I pull these battery chargers apart is to sort of have a look and see whether I've got high voltage on the control board. Okay, so there's a test point 1 and 2 across this capacitor here. And coming up from the transformer below, we should get a rectified DC volts of about 60 to 70 volts that does all of the regulation and whatnot to charge the battery. So that's the very first thing you should check. Do I have voltage here? If you don't, the problems are either associated with some driver transistors, rectifiers, transformers here, or something to do with the pulse generation on the bottom board. In this case, I had my high voltage up here, which was good. Okay, so the problem lies on this particular board. So before we get into that particular board, let's have a look at the circuit diagram and see just how it operates. Okay, if you look up the manual for these particular battery chargers, you'll see that this unit 4, and by the way, the top board is unit 4. This is the circuit for unit 4. So before we get into it, let's have a look at the different areas of the board, what they do. Okay, so we've got some big regulation transistors that live in the board below. This one here, they're fed up here into the board. We've got another regulation transistor that lives down in here that actually supplies 12 volts up here to the board, a separate 12 volt supply. So this particular regulator here is the regulation for the charging of the battery, and this particular regulator here supplies the 12 volts for all of the control, logic and switching for the battery charger. So as I say, this is the logic and switching area for the battery charger, and this is the power regulation. So let's look at the control. Okay, so let's start with up here. Up here, we're looking at the current limit area, particularly around this resistor here. and the voltage drop across that resistor it pertains to give the circuit information for the current limit. Okay, so the whole idea of the charger is to maintain a constant current of about 1.25 amps over the full range of the charging. So how the charger regulates the charge rate to keep the current constant and to give a varying voltage as the voltage on the battery builds up, and then the logic here will cut the voltage off at a certain time and indicate that the battery's full, and that happens around about 32 volts. Okay, so how does it do the regulation? It does the regulation here by this section here, and this section here is a pulse width generator. So this varies the pulse width of a constant frequency of around about 12K, I think it is. So as the pulse width changes, the average voltage changes, and it increases as the battery charges up. Okay. Now look, that's basically how it works. So let's get into the particular fault that I had, and it may help some people do a little bit of fault finding of their own. Okay, so how does the pulse width sort of do its stuff? Okay, so it pertains, well, it gets a voltage from over here, which arrives at test point 4, and test point 4 has got around about, I think, about 15 volt Zener diode across it, and then up we go here through another little bit of a dropping resistor to test point 3, and we have around about I think that says 5.6 or something, around about 6 volt Zener there. So the first thing we want to find out is, in fact, do we have voltage to our pulse train here generating part of the circuit? So yeah, let's have a bit of a look at test point 4 and test point 3. So if you jump onto the manual, oh, we've got a bit of glare there. If we jump onto the manual, it's got this wonderful little chart here that helps us out, so to speak. Okay, so if you look at the test point, where are we? Test point 3 and test point 4, they're measured in reference to test point 1. So if you have a look across those two Zeners at the two test points, you'll see around about 15 and 6 volts we should have there. And by the way, this particular chart that's here, it's to be used in association with the test rig. And the test rig uses, in place of a battery, 330 ohm resistor. But if you connect the battery up to your battery charger for fault finding, these voltages aren't exactly what they are here, but they should be very close. Okay, so use these as a guide. Okay, so off we went over here. Let's have a look at where these test points are. Okay, there's test point 4 just there. I think this battery charge is on, so I better watch out. Test point 4 is there, and I think test point 3 is over there. Okay, so that's where the two test points are. Yeah, as we said, test point 4, test point 3. So in my case, I've jumped onto those test points and found them to be approximately what you'd expect to see in the chart. All good, all good. Now, down here, out of our pulse generating section, we get a biasing voltage to turn on the regulator. And as I say, this varies as the battery charges up. So, first of all, have we got bias on our regulator? Have we got bias? So, let's have a look and see what we should have at test point 4. Okay, so where are we? Or I should say that's not test point 4. That's pin 4. Pin 4. So if we look at a pin 4 in association with test point 2, we should end up with something around about 1.5 peak to peak. Now, I've found out that 1.5 peak to peak, again, is associated with the 330 ohm resistor, which is a flat battery. But as the battery charges up, the voltage here, peak to peak average voltage, drops off to, something around half a volt or something like that as it's heading up towards being fully charged. So in my case, I've gone over to the terminals, which is terminal 1, 2, 3, 4, and tested that in reference to test point 2. And in my case, lo and behold, nothing. I didn't have any voltage whatsoever. So that's telling me that I've got my applied voltage, my control voltage here, but I've got nothing coming out. So my next thing was to find out, did I in fact have the applied voltage here for the pulse train generator. So I jumped on and I put the meter onto that side of that resistor, and I had my very, very high voltage here. I think it was around 50 something volts. And then as soon as I put my meter on this side of my little resistor, boom, lo and behold, the battery charger started to work. So I had a hot joint on this particular resistor, R5, which is right there, R5 in my case. As soon as I put my meter on there, boom, the charger started to work. So yeah, I re-sweated, or I should say re-soldered, this particular resistor. Yeah, cleaned it, you know, made sure that there was conductivity was there, the joint was good again. And I think we've still got it on go. Yeah, there it is there at the moment. Yeah, so the yellow light's on. The battery's charging, which is good. If I look at my, I know I've got a messy bench, I keep saying that, but it doesn't matter, I don't care. Okay, so we've got, yeah, there's the voltage, and there's the, oh, that's the voltage that I've applied to the thing. It's probably not quite high enough. I need to turn that up on my power supply, but yeah, you can see that current there. That's the current that the entire charge is drawing, a little over 2 amps. So she's madly charging up that battery there at the moment. So yeah, in my case, I was lucky. All I had was a crook joint on the resistor, which got this particular battery charger back to life. But if I hadn't, if I did have voltage on there and we were getting no pulse generation, then I would have been looking at these transistors here that do the pulse generation and finding out why that this part of the circuit wasn't operating. But I was just lucky. I was just lucky this particular time. So that brought the charger back to life. So, in conclusion, we've brought back to life one of these beautiful battery chargers. Very, very complex bit of equipment for what it actually does. Yeah, back in the day, built very, very well to very, very high standards. If it was probably built today, it would be a much, much simpler, much smaller device. But the whole point of the exercise is to keep our original Clansman gear operating. So I hope that particular explanation of my little escapade today will help somebody out there in the world get their battery charger back together. Thank you very much, everybody, for tuning in. This is Victor Kilo 2, Papa Radio Charlie 73. Catch us all in another video. Bye-bye.